Hope you all doing good. Okay. Yes. Hope your studies are going well. Today we are going to discuss about a new topic from some basic concepts of chemistry, and it is one of the interesting topic, and it is the one of the most important topic as well, right? Okay. So here, before going into the topic, you can just see our full year course, what we provide. Okay. So you can just read it over here, and what all materials or what all things we provide for our students. You can see that we provide the PDF materials of the complete modules as well as the question banks, and there are test series, 25 major test series we conduct as per the NTA pattern, and you can also have query solving with teacher each 2 days. Okay. And also lessons will be given to you, assignments will be given to you, that will be checked, and you will be having a personal mentorship. Okay. So with all this program you are getting from our academy. Okay, right now, and we just cost only 490 rupees. So it's an amazing price. You can crack JEE or NEET with this much enormous discount. It's not for 3,990, it's just for 490 rupees, right? Okay, now let's get started. And if you are new to this channel, you can subscribe to our channel, because we are giving free content regularly on our YouTube channel. So you can subscribe to our channel and you can make use of it. Okay. Now, dear students, my name is Roshan Ahamed. I am an MTech postgraduate, a National Olympiad winner, and I have a 6+ years of experience and almost guided more than 1 lakh students to crack the exam. Right. So, coming on to today's topic, we are going to discuss about the stoichiometric as well as the limiting reagent. Dear students, stoichiometry and limiting reagent is one of the most important topics from the mole concept. You know that, and it's not only in the competitive exam but also in the our board exams also. It is so important topic that we can see in the previous year question paper there have been repeated questions coming from this topic. So you have to be very much aware of this topic, and let's start with again with the basics of this. So first we will discuss about what do you mean by percentage composition of a compound. See students, if you consider a compound, we know that there will be different elements will be present in that compound. For example, if I take ethane, you can see here ethane, C2H6. So in C2H6 we can see that there is carbon is present as well as there is hydrogen is also present. Okay, so carbon and hydrogen together combines together, and they combine together to form what? To form C2H6, right? So let's see, we can just calculate the total mass of this molecule. We know that the gram atomic mass of carbon is 12. So 2 into 12 plus 6 into 1. We know the mass of hydrogen is 1. So we get here the total mass is equal to 30 gram per mole. So for 1 mole, we get it as 30 gram. Okay, that is the mass of C2H6, right? So here in percentage composition, we will be calculating the individual contribution in mass of each element. That means how much percentage of the total compound's mass is contributed by carbon, as well as we also calculate how much percentage of mass is contributed by hydrogen to ethane. So how we can find out the total contribution or the contribution of masses of each element? So let's check that out. So let me calculate first. See, here you can see a question. Let's solve this question, then it will be clear for you that we have to find out the percentage mass of carbon and hydrogen in C2H6. Okay, so let's see here, percentage carbon is equal to mass of carbon divided by total mass of compound into 100. This is the formula to find out the individual contribution in percentage. Okay, individual contribution of mass by each element in percentage. So here we know that in C2H6 there are 2 carbon atoms. That means the mass contributed by carbon is 24 gram. Divided by total mass is 30 gram. Here we have already found out. So 24 divided by 30 into 100. So if you can cut the numerator with 6, you will be getting 4. Cut the denominator with 5. With 6 you will be getting 5, and 5 and 100 you can cancel it by 20. Okay, because 5 into 20 is 100. So 4 into 20 means 80%. What does that mean? In the total mass of C2H6, the contribution of carbon is 80%. That means the 80% of mass of C2H6 is coming from carbon. Okay, now let's calculate the mass of hydrogen. Let's calculate the mass of hydrogen. That is percentage mass of hydrogen. So in percentage hydrogen, mass of hydrogen divided by total mass into 100, right? So what is mass of hydrogen in C2H6? We know that it is 6 hydrogen atoms is present. So I'll give it as 6 divided by total mass of the compound is 30 into 100. So I can cancel here 6 and 30 by, because 6 and 30 by 5. That means 6 into 5 we will get it as 30. So 5 and 100 can be cancelled and we will be getting it as 20%. See students, if you are considering the total mass of a compound as 100% and there is only 2 elements and one element is contributing 80%, then the next element will obviously contribute 20%. That's a common logic, right? So you can just simply, by finding, if there is only 2 elements, then simply finding the percentage of one of the element, then you can find out the other element by just subtracting that particular value with 100. Okay, that means 100 minus 80 will give you the percentage mass of hydrogen. So anyways, you can do in both the ways, right? Okay, now let's move on to the next one. See, we are going to calculate the percentage composition of glucose. So how you are going to calculate the percentage composition of glucose? First of all, we have to find the total mass of glucose, right? So let's calculate the total mass of glucose. So total mass of glucose is equal to, we know that there are 6 carbon atoms. So 6 into 12, 12 is the atomic mass or gram atomic mass of carbon, plus 12 into mass of hydrogen is 1, plus 6 into mass of oxygen is 16. Okay, so 6 into 12 is 72, plus 12 plus 16 into 6. Let's calculate. 16 into 6 is 96, right? 96. So 96 plus 400, 100 plus 10, 80 means 180. So the total mass of glucose is 180 gram per mole. So we got the total mass of glucose as 180 gram per mole. Now let's calculate the percentage composition of each element. Let's calculate the percentage composition of carbon. Percentage composition of carbon is mass of carbon. What is the mass of carbon in glucose? That is, we know that it is 6 into 12, that is 72, divided by 180 into 100. Okay, now you can cut this with 9. 9 8s are 72 and 9 2s are 18. So here it comes 20. 20 into 100 you will get 20. 100 divided by 20 is 5. 5 into 8 is equal to 40. So here we got the percentage of carbon as 40. Now let's calculate the percentage of hydrogen. Okay, percentage hydrogen. So what is the mass of hydrogen in glucose? That is, we know that 12 hydrogen atoms is present. So mass of one atom is 1 AMU or 1 gram per mole. So it is equal to 12 divided by 180 into 100. So here you can cancel 1 0 0 and here you can cancel by 6. 6 into 2 is 12 and 6 into 3 is 18. So 2 by 3 into 10, that is 20 divided by 3. 20 divided by 3 means 6.67%. 6.67%. Right? Now let's calculate the percentage contribution of oxygen. So oxygen equal to, we know that the mass of oxygen is 6 into 16, that is 96, divided by 180 into 100. Okay, now you can cancel here. You can cancel this with 3, it will be 32. Here it will be 6. You can cancel with 2, that will be 3, and here you will be getting 16. And 16 divided by 3, what will be the value of 16 divided by 3? 5 times, that is 15. 1, you will give a decimal, then it will be 0. So 3 times 9, again 1, so 5.33, like that it goes. So 5.33 into 10, yes, 5.33 into 10, that is 53.33 percentage. So that's all. So you got the mass percentage, or the percentage of carbon is 40%, and percentage of hydrogen is 6.67%, and percentage of oxygen is 53.33%. Okay students, now let's move on to the next one. Hope this is clear for you, right? Now the interesting one is urea. Now similarly we have to find out the total mass of urea. Let's find out the total mass of urea. So total mass of urea is equal to, we know that there are 2 nitrogen atoms, so mass of nitrogen is 14, so 2 into 14 is 28. I am just writing is direct. And here we have 4 hydrogen atoms, so it will be equal to 4 plus 1 carbon atom, that is 12, 1 oxygen atom, that is 16. So here we will be getting 32, 42, 44, 54, 60. So the total value is equal to 60 gram per mole. Right? So that is the molar mass of urea. Now we have to find out the percentage nitrogen. So percentage nitrogen, percentage hydrogen, percentage carbon, percentage oxygen, all the elements we are going to find out. So we know that percentage nitrogen, the mass of nitrogen is 14, and there are 2 nitrogen atoms present. So 28 divided by 60 into 100. So we can cancel 1 0 0, and here you can cancel it by 2, that will be 14. Here you will be getting 3. So 140 divided by 3. Let's calculate it. 140 divided by 3. So 3 4s are 12. Okay, 20. 3 6 are 18. So again we are getting 2. So give a decimal point. 20. Again you can do it 6. Again 18. It goes like that. So we can conclude it as the mass percentage of nitrogen is 46.67%. Right. Now the next one is percentage hydrogen. Percentage hydrogen is equal to, we know that the mass of hydrogen atom is 1 and there are 4 atoms. So 4 divided by 60 into 100. You can cancel zeros and you can cut it with 2, and here you will be getting 3. So 2 by 3 into 10, that is 20 by 3. 20 by 3 means 6.67%. 6.67%. Next is percentage carbon, that is 12 divided by 36. Sorry, 12 divided by 60, right? 12 divided by, yeah. So 12 divided by 60 into 100. Here you can cancel the zeros and here you can cut it, and you will be getting 2, that is equal to 20%. That was easy, right? We got that 20% in just 1 second, right? The next one is, the last one is percentage oxygen, right? Percentage oxygen. So in order to find the percentage oxygen, you can count the total, add the total, that is 46.67 plus 6.67, that is 53.2 or 53.34 plus 20, that is 73.34. Then almost it will be equal to 26 point something, right? So we will calculate the other way also. Percentage oxygen is 16 divided by 60 into 100. 0 0 we can cancel this with 2, 8, and here we will be getting 3. So 80 divided by 3, 80 divided by 3, so 2 times it will be 6, so 20, it will be 26 Yes, 18 and 26.67. So we got the mass percentage of oxygen is equal to 26.67 percentage. Yes. So that's it, students. So we have calculated successfully, we have calculated the mass percentage of each element present in urea. Next is we are going into the empirical formula. Dear students, what do you mean by empirical formula? Empirical formula, it simply represents the simplest ratio of atoms of different element in the compound. Okay, it simply represents the ratio of atoms present in the ratio of atoms of different elements in the compound. So it should be a simplest ratio. So this you will get to know what empirical formula while once we start doing the problems related to empirical formula and molecular formula. For time being, I'll give you a hint or I'll give you an example. Here you can see I have given the molecular mass of benzene. So we know that the molecular mass of benzene is C6H6, right? Here 6 and 6 is common, so you can just remove that 6. So you will be getting 1:1, right? 1:1. If you divide both the 6 with 6, you will be getting the ratio as 1:1. So according to benzene's molecular formula, 6 carbon atom consists of 6 hydrogen atom. The ratio between the elements is 6:6. So if you cancel the common number, you can cancel the common number in order to convert it into the simplest form. So how you are going to convert it into the simplest form? By cancelling the common term. Here 6 is common, so I can cancel. So I am getting the ratio as 1:1. So 1:1 is the simplest ratio. So what will be the empirical formula of benzene? Empirical formula of benzene will be C1H1. Yes, this is how we represent the empirical formula. Similarly, you can see here glucose, you can see C6H12O6, that is the molecular formula of glucose. So you can write it as here it is 6:12:6. Now we have to convert it into the simplest ratio. So for converting into the simplest ratio, what we have to do? We have to cancel the common term. Common term is 6 here. In all the three, the common is 6. So you can cancel that 6. So you will be getting 1:2:1. How I got 2? Because 12 can be written as 6 into 2. By cancelling 6, then there will be 2 will left around. So 1:2:1 is the simplest ratio. So the empirical formula of C6H12O6 is C1H2O1. Okay, hope this is clear for you, right? So what is the empirical formula? It simply represents the simplest ratio of atoms of different element in the compound. So what is the simplest ratio between the elements? So empirical formula is not going to give you the actual molecular formula. Okay, there are certain cases where in certain compounds the empirical formula and molecular formula are same. Okay, so but generally both are different, but there are cases where empirical and molecular formula are same. There are compounds like that, so that's not a big deal. Now what about molecular formula? Molecular formula, it represents the actual number of atoms of different element in one molecule. So actually the molecular formula gives us the actual number of atoms present in one molecule. So see, in the case of benzene, we know that in benzene there are 6 carbon, there are 6 hydrogen. So the molecular formula exactly gives us the actual number of atoms present in that molecule. So C6H6. Similarly, in the case of glucose also, we can see that the molecular formula is C6H12O6. That means there is 6 carbon is present, 12 hydrogen is present, and 6 oxygen is present, right? Okay. Now here students, let's see. In certain question papers, they normally use the term least molecular mass. See, you have to remember this, that whenever they are mentioning about least molecular mass, it is nothing but empirical mass. You know, it is nothing but empirical mass. So what is empirical mass? It is nothing but empirical formula mass. Once you obtain the empirical formula, then just find out the mass of that empirical formula. That is that is meant by empirical mass. Okay, once you got the empirical formula, so for example, in the case of benzene, we found out the empirical formula CH, right? So what will be the empirical mass of CH? 12 plus 1, 13, right? So that is what is meant by empirical mass. So here you can see a question, find the empirical formula of acetic acid. So for this question, you have to first find out what is the mass of, what is the formula of acetic acid. So let's write the formula of acetic acid, that is CH3COOH. So I am just reorganizing or rearranging this formula to C2H4O2. Okay. So once you reorganize or rearrange the elements in such a way, then now we can think about the ratio. The actual ratio is 2:4:2. This is the actual ratio that corresponds to the actual molecular formula of the compound. Now we have to cancel the common one. What is the common term here? You can see that 2 is common in everyone. So you can cancel that 2. So you will be getting a ratio of 1:2:1. So this is the corresponding ratio or the simplest ratio that corresponds to empirical formula. So I can write that the empirical formula of acetic acid is equal to C1H2O1. C1H2O1. And also I can find the empirical formula mass. Empirical formula mass is equal to, in empirical formula there is only one carbon, so I can write 12, plus in empirical formula there are 2 hydrogens, so I can write 2 into 1. In empirical formula there is only 1 oxygen, so I can write it as 16. So the total is 28 plus 2, that is 30 gram per mole. So that is the empirical formula mass, right? So dear students, I want to introduce another term for you. That is, there is a value called N, and this N value is equal to molecular mass divided by empirical mass. Molecular mass divided by empirical mass means empirical formula mass. So why I have to find this value, N value? See, if I am given with empirical formula, I wanted to find out the molecular formula. If I am given with empirical formula, I wanted to find out molecular formula, then what will be molecular formula? Molecular formula is equal to empirical formula into N. So that is why we have to find out the value of N. So what is the value of N? N is equal to molecular mass by empirical mass. Molecular mass by empirical mass. So in order to find out the molecular formula, we have to find out, first we have to find out the number of the N factor, the N value. Then you can multiply it with the empirical formula. Then you will get the molecular formula. So molecular formula equal to empirical formula into, right? Now let's see. Calculate the empirical formula, or a calculation of empirical formula by percentage composition is what we are going to discuss. So here, see students, we are given with 2 compounds, 2 elements, right? Carbon and hydrogen. See, this can be done very easily if you follow the right sequence that I am going to give you. First, we will take the element. Okay, so first you write the element. So what all elements are present here? We know that we have carbon, we have hydrogen. Now let's write the percentage mass here. What is the percentage mass? We know that it consists of 80%. So we will simply write it as 80, and percentage mass of hydrogen is 20. Now see students, we are converting them into number of moles. Here what do you mean by number of moles? Number of moles is weight or mass by molar mass. Here also we can write mass by molar mass. So 80 divided by gram atomic mass or molar mass of carbon is 12. Similarly, 20 divided by gram atomic mass of hydrogen is 1. So equal to, we will be getting a value of 80 divided by 12. So let's calculate 80 divided by 12. So let's cut it with 3 times, and here it will be 20. So 20 by 3 is nearly equal to 6.67, right? So here we will be getting around 6.67 and here we will be getting around 20. So now we found out the mole. Now we have to find out the mole ratio. Mole ratio, how to find out the mole ratio? Among these two values, you have to select the lowest number of moles and divide the lowest number of moles with both the values. So here I will be getting 6.67 divided by 6.67. That will be equal to 1. Here 20 divided by 6.67, that will be nearly equal to 3. Right. So we got the mole ratio and this is the simplest ratio that we require. So now we have two elements, that is carbon and hydrogen, and the ratio of carbon is 1 and ratio of hydrogen is 3. So we can simply write C1H3 is the empirical formula of the given compound. Right. So this is how you have to go through the problem. So first give the element, that is carbon and hydrogen, then write the percentage mass, then find out the number of moles, then you just find out the mole ratio. The mole ratio will give you the simplest formula or simplest ratio, and that simplest ratio along with the elemental representation, you will get the empirical formula of that compound. Right. Now let's move on to the next one. Here see students, this is if vapor density is 15. See, if vapor density is 15. Yes, Vivek Thomas, hi. Vapor density is 15. You have to find out the molecular formula. See how you can find out the molecular formula. This you have to understand, this is just the B part of the first question, right? So this is just the B part of the first question. So here vapor density is given, then how vapor density is related to the molecular mass, that is what we have to find. See here you have to find out the molecular formula, right? And I have told you molecular formula is equal to empirical formula into N, right? So what is N? N is equal to molecular mass divided by empirical formula mass. So N is equal to molecular mass divided by empirical formula mass. So what is molecular mass? We don't know. Empirical mass we can find out, right? From the previous case, here we got the empirical formula as C1H3. So what is the empirical mass? From here we can calculate the empirical mass. Empirical mass is equal to, there is only one carbon, so 12 plus 3 hydrogen plus 3, that is equal to 15. Yes. We will be getting the empirical formula mass equal to 15. So you can just we got the empirical formula. Now we need to find out the molecular mass. Yes, we need to find out the molecular mass. What is the molecular mass? Molecular mass is equal to 2 times vapor density. This is a very important relation. Molecular mass is equal to 2 times the vapor density. So molecular mass equal to 2 into 15, that is equal to 30, right? 2 into 15, that is equal to 30. Now let's see. Now we can find the value of N, right? N is equal to, molecular mass is 30, empirical formula mass is, what was the empirical formula mass? Empirical formula mass was 15. So 30 divided by 15, that is equal to 2. We got the N value equal to 2. Now we can find out the molecular formula. So molecular formula equal to empirical formula into N, right? That is 2. What is empirical formula? We just find out empirical formula as C1H3. So C1H3 into 2, C1H3 into 2, that is C2H6. That is equal to C2H6. Right? So that is the molecular mass or the molecular formula of the compound. So here this relation is very important, that is molecular mass is equal to 2 times vapor density. So in certain question paper they will be giving you vapor density or they will directly give you the molecular mass. Okay. So if vapor density is given, you can convert it into molecular mass by this formula, that is 2 into vapor density will give you the molecular mass, right? So we will move on to the next one. See, another question. Here percentage composition by mass of a hydrocarbon is as follows. Percentage composition, that is percentage carbon, is given. We have to calculate the empirical formula. Yes, we have to calculate the empirical formula. Let's see. Here we know that it is hydrocarbon. Hydrocarbon means we know that it consists of hydrogen as well as it consists of carbon, right? So we have to first find out the empirical formula. So let's before getting started, let's calculate the percentages, right? So here it comes. Yeah. Okay. Now see, we know that it is 600 by 11. That means we will assume it as the percentage is 600 by 11. That means we assume it as 600 by 11 gram. Okay. And similarly, hydrogen will be, what will be the value of hydrogen? You know that the percentage should be 100. So if this is 600 by 11, then obviously what will be the percentage of hydrogen? Percentage of hydrogen will be 100 minus 600 by 11. No doubt. You have to subtract the 600 by 11 with 100. So you will be getting it as 1100 minus 600 divided by 11. That will be equal to 500 by 11. Right? 500 by 11. Okay. Now the number of moles. We will calculate the number of moles. Now the number of moles is equal to 600 by 11 is the given mass. Molar mass of carbon is 12. Similarly, here also we can calculate the number of moles, that is 500 by 11 is the given mass and molar mass is 1. Okay. So here we get the value as 600 divided by 11 into 12. So if I can cut with 6, so this will be 100, 2 and this will be 50. So here we are getting a value as 50 by 11 as the mole ratio. 50 by 11 as the mole ratio. Here we are getting a value as 500 by 11 as the mole ratio. Right? Anurag, don't worry. You keep on preparing, give your best. Okay? Keep attending the classes, revise properly. Okay, once you are getting more fear, if you are getting more fear, that means you are getting out of the competition. So don't allow yourself to get feared. You have to focus on your work. So keep focusing so that you can come up with great marks. Okay, don't worry about that. So here let me write it once again. We got it as 50 by 11 as the mole ratio and 500 by 11 as the mole ratio of hydrogen. Now we have to take the mole ratio which is the smallest mole ratio and we have to divide it in order to get the mole ratio, right? We got the mole, now we have to find out the mole ratio. So finding out the mole ratio means 50 by 11 is the small value. So we can divide both the moles with 50 by 11. So here we will be getting 1 and in the second case we have 500 by 11. If you divide it by 50 by 11, so we will be getting 500 by 11 into 11 by 50. That means 11 and 11 get cancelled and 50 and 500 get cancelled and we get the value as 10. So the mole ratio is equal to 1:10. 1:10. So what will be the empirical formula? Empirical formula is C1H10. So simple, right? So there is a slight confusion from this part here. They just gave us only the percentage of carbon. So we, using our brain, we have to find out that they already have told us it is only hydrocarbon, means hydrogen and carbon is only present. If carbon is 600 by 11, then hydrogen will be 100 minus 600 by 11. Okay. So this is how you have to solve the problem. Now we are moving on to the next one. See, the percentage composition by mass of a compound is as follows. Percentage nitrogen is given, percentage oxygen is given and 4 options are there. You have to pick the right one. So how you are going to find the answer? Let's start. Okay, we have 2 elements, nitrogen, one is nitrogen, the other is oxygen. So we have percentage composition, that is 26 and 74. Now convert them into moles. 26 divided by 14 and 74 divided by 60. So what is 26 divided by 14? That is nearly equal to 1.85, and 74 divided by 16 is 4.625. Okay. Now we have to find out the mole ratio. Mole ratio will give us the simplest ratio. So 1.85 is the smaller value, so divide it by 1.85. Both the values you divide by 1.85, so you will get 1, and 4.625 divided by 1.85, you will be getting a value equal to 2.5. So whenever you get a fraction or you get a decimal, convert it into fraction, that is 2.5 is equal to 5 by 2. So here you got the values, that is N1 and O 5 by 2. So in empirical formula as well as in molecular formula, you will never find a fraction. So you have to remove this denominator. For removing the denominator, you can multiply the whole value into 2 so that the denominator will get cancelled. So if I multiply with 2, I will get N2O5. See? So the answer here is 3, that is N2O5. So we got the empirical formula. It's a very interesting question. You have to remember this. And also, if you are getting a mole ratio of 1:1.33, you have to convert it into 1:4 by 3 as the fraction. 1:4 by 3. Always remember these fractions. And similarly, you will be given with 1:1.25. In such a case, you can convert them into 1:5 by 4. So always remember these fraction values once you get the decimal values like this. Okay. Then you can convert it into, you can cancel the denominator by multiplying the denominator with the total value. So that will give you the correct answer. So always remember these 3 points. Okay. That is 2.5. When it is 1:2.5, then it is 1:5 by 2. So these 3 points you have to remember in your mind. Right. Okay. Now let's move on to the interesting topic, that is we are going to discuss about the mole analysis. And see, mole analysis is a very important tool which will help you solve many problems that comes from the stoichiometric as well as the limiting reagent point of view. So let's discuss what actually mole analysis is. Right. Okay. So mole analysis is normally done. We normally do mole analysis for only balanced reaction, for balanced chemical reaction. So in order to do mole analysis, you have to balance the chemical reactions, right? And the second one is the stoichiometric coefficient should be known for each reactant and product. So if the chemical reaction is already balanced, then by automatic you will get to know about the stoichiometric coefficient of the reactant and product. So stoichiometric coefficients should be known for each reactants and products. Should be known for each reactants and products. Right? Okay. Now let's see an example. Here's a reaction, N2 plus H2 giving NH3. So when you get a reaction and which looks like unbalanced, you can see here there is hydrogen is 3 and here it is 2. Here it's 2 nitrogen, here is just 1 nitrogen, so it is unbalanced. So first of all, first step you have to do is that you have to balance it, right? So how to balance? You know that if here it is 3 and here it is 2, then you can multiply it with 3 here and you can simply multiply it with 2 here. So just multiplying the values in the reverse order. If the product contains 3, then the reactant you multiply with 3, and if the reactant contains 2, you multiply with 2 in the product. Okay. So N2 plus 3H2 giving 2NH3. So now the reaction is balanced. Now the second step is you just write down the stoichiometric values. Stoichiometric value of nitrogen is 1. What is stoichiometric value? The number behind the letter. This is the letter, and is there any number here? No number, that means it is 1. Here you can see before hydrogen, you can see there is 3. So that is 3 is the stoichiometry of hydrogen and 2 is the stoichiometry of ammonia. Okay. Now what is mole-mole analysis? Mole-mole analysis means number of moles of N2. Moles of N2 by stoichiometric coefficient of N2 is equal to moles of H2 divided by stoichiometric coefficient of H2 equal to moles of NH3 divided by stoichiometric coefficient of NH3. See, by simply writing this, you can find out the number of moles of product formed, right? How? Because the moles of N2 will be given, stoichiometry of N2 we know that from the balanced reaction, or the moles of H2 will be given, and stoichiometry of H2 can be is already given in the form of the balanced reaction. So you will be asked to find out the number of moles of ammonia. You can find out the number of moles of ammonia by equating either with this or either with this. You can just use any of the equation, because all the 3 components, all the 3 ratios are mutually equal to each other, right? Okay. Now we will do a problem so that you will get to understand how to solve this problem, right? So let's do a problem. We have 2 cases in mole-mole analysis. Let's complete that both the cases. So let's move on to the next slide. See, case 1. Here, what is the case 1? Case 1 says that if moles of reactions are taken in same ratio as stoichiometric ratio, all the reactants may be consumed completely. What does that mean? Here, let's see, I am giving you an illustration. N2 plus 3H2 giving 2NH3. This is the balanced reaction of Haber process, right? Here you can see the stoichiometry of nitrogen is 1, stoichiometry of hydrogen is 3, okay? And similarly, if I am telling you that the number of moles of nitrogen is 1 and number of moles of hydrogen is 3, then you can see that the ratio here is 1:3, and here also moles also the ratio is same. Or if I tell you that I have taken the number of moles of nitrogen as 2 and number of moles of hydrogen as 6. Let's think about this. So 2:6 means it is equal to 1:3 itself. So if the mole ratio and the stoichiometric ratio are equal, then this reaction will not generate any limiting reagent or excess reagent, because if the stoichiometric ratio and mole ratio are equal, then both the reactants will get consumed completely. No reactant will be excess or no reactant will be limiting. Hope that is clear. Now let's do this problem. How many moles of ammonia are formed by reaction of 3 mole of N2 and 9 mole of H2? So let's do this. N2 plus 3H2. First you have to write the balanced equation, 2NH3. So next you have to write the stoichiometry, that is stoichiometry is 1, here it is 3, here it is 2. Now what is the number of moles? Number of moles here it is 3 and here it is 9. So we know that both the ratios are same, okay, both the ratios are same. You have to find out the number of moles of ammonia. Now apply the mole-mole analysis. What is mole-mole analysis? Number of moles of N2 by stoichiometry of N2 equal to number of moles of H2 by stoichiometry of H2 equal to number of moles of NH3 by stoichiometry of NH3. So I am just using this 2 relation, okay. Number of moles of H2 is given as 9, okay. So it is 9 divided by 3 equal to number of moles of ammonia is what I have to find out. Stoichiometry of ammonia is given as 2. So we got it as 9 NH3 equal to 18. Sorry, number of moles of NH3 equal to 18 divided by 3. How I got 18? 9 into 2 is 18. 18 divided by 3 is equal to 6 moles. Okay. So, we got the answer as 6 moles. So, this is that much easy, right? This is that much easy to do the problem. So, you may not find it here, right? Okay. Hope this is clear for you. So, I will just write it over here. Number of moles of ammonia is equal to 18 divided by 3, that is equal to 6 moles, right? Okay. Okay, students, next we will move on to the next one. If the moles of reactant are not taken in the same ratio as their stoichiometric ratio, then one reactant is completely consumed, which is called as a limiting reagent, and the reagents which are left over are called as excess reagent. See students, here you have to understand that if the mole ratio and the stoichiometric ratios are different, then what happens? Then obviously the reactants will not get consumed simultaneously. What happens is that if the mole ratio and stoichiometric ratio is different, then there will arise a condition of limiting reagent and excess reagent. One reagent will be excess and the other will be limiting. What do you mean by limiting? Limiting reagent means those reagents which get completely consumed. So, those reagents which get completely consumed is called as limiting reagent, and those reagents which are excess, which are left after the completion of reaction is called as excess reagent, right? So, hope that is clear for you. Now, let's do a problem. Okay. Take a new page. I'll give you a question here. Yes. Dear students, if you have any doubt, you can just comment me so that I can see if you have any doubt, so that I can give you a good reply for that. So let's discuss a question. So here divide so I'll give you a question. So this is the question: A plus 2B giving C. Okay. Now the number of moles, here you can see the stoichiometry is 1, 2 and 1, right? Now what is the number of moles? Number of moles given here is equal to, here you have 5 mole, here you have 20 mole. So this is given in the question, right? So I have to find out the limiting reagent. Find the limiting reagent of this reaction. We have to find out the limiting reagent of this reaction. See how to find out the limiting reagent? You simply calculate what is N by SC. Just calculate N by SC. So here it is number of moles is 5 divided by 1, that is equal to 5. Okay. Now here we have 20 divided by 2, that is equal to 10, right? So which reagent is having the least value of N by SC? That reagent is the LR, and which reagent is having the most value of N by SC? That reagent is the ER, that means the excess reagent. So this is how we calculate the limiting reagent and excess reagent in a very easy step, right? So one more thing I have to clarify here. If you are asked to find out the number of moles of C, then what we will do? We will just write the mole analysis, that is number of moles of A by stoichiometry of A, that is 1, number of moles of B by stoichiometry of B, that is 2, and number of moles of C by stoichiometry of C, that is 1. See, if in a question there is limiting reagent, then you should not consider the excess reagent in order to find out the number of moles of the product. You only have to compute with the limiting reagent formula. If you are not computing, if you are going to take the value of NB, then the NC, number of moles of the product, will be wrong. So always be aware, in the case of limiting reagent, only use the formula or only use the data of the limiting reagent. But in the other case, if in the case 1, we do not have any such difficulty, because we do not have any condition of limiting reagent or excess reagent. So you can take Na by 1 or Nb by 2 equal to Nc by 1. You can take either Nb by 2 to equal to Nc by 1 in order to find out the number of moles. So see, no problem there. But if you are having a case where there is limiting reagent, then surely you only have to use the data of limiting reagent, otherwise your answer will go wrong. So I am just cancelling this one, since Na is the limiting reagent here. So I can just put the value of number of moles of limiting reagent, that is 5 moles, and 5 by 1 is equal to number of moles of C. So number of moles of C is equal to 5. So that's how you solve the problem with regards to the limiting reagent. So you can find out the limiting reagent by just writing the N by SC value, and see the N by SC value, the minimum value of N by SC will give you the limiting reagent. So let's do another problem. Okay, let's do another problem. So here's a question. Let's take a new page. Here's a question. A plus B giving A2B3. So initially 6 mole of A and 20 mole of B are taken. After reaction, calculate. What you have to calculate? The first one is LR, second one is number of moles of A comma B and A2B3. Okay. Now you can see that A plus B giving A2B3. First of all, what you have to do in order to apply mole analysis, you have to balance the equation. Here the equation is not balanced. In the product there is 2A and the product there is 3B. So you can just balance it by writing 2A plus 3B will give you A2B3. Now what you have to write next? Just write down the stoichiometry, that is 2, 3 and 1. What is the number of moles? Number of moles is initially 6 moles of A, so 6. Here 20 moles of B, so 20. Here we do not know. So first we will find out whether there is, yes, obviously you can compare 2:3 and 6:20 are different. So there will be a limiting reagent. So N by SC you will get it as 2 by 6, that is equal to 1 by 3 and 3 by 20. So which will be the least one? Obviously 3 by 20, right? So 3 by 20 is the least one. So that means the LR is, B is our LR, right? Oh, it is N by SC, I just did the wrong way, right? N by SC, for N by SC I have written the value of SC by N. Here it is 6 by 2 and here it is 20 by 3. 6 by 2 will give you 3 and 20 by 3 will give you 6.67. That means the LR is, A is our LR. Okay. Now we will write the mole analysis equation. So while writing the mole analysis equation to find out the moles of B, so moles of product, then you only have to use the data of the limiting reagent. So I will write N number of moles of A by SC equal to number of moles of A2B3 by SC. SC of A2B3. So number of moles of A is 6 moles, SC is 2 and number of moles of A2B3 is, we do not know, we have to find that, divided by number of SC is 1. So number of moles of A2B3 you will get it as 6 by 2, that is equal to 3. Yes, that's our answer. Clear? An interesting question, right? Yes. Now let's do one more problem, then we will wind this session. Right, so one more problem. We will be dealing with an actual problem here. So you can just note this down, that is 54 gram of aluminium and 320 gram oxygen gas oxygen gas react to form Al2O3, right? Calculate mass of Al2O3 formed. So you have to find out the mass of Al2O3 formed. So here what is the equation? Just write the equation first. Al plus O2 giving Al2O3. We know that here if it is 3 and here it's 2, you multiply both with the opposite numbers, that is multiply 3 here and multiply 2. So you get 6 is balanced. Now aluminum is 4, so you can give 4 here. Now the reaction is balanced. You can just write the stoichiometry, that is 4, 3. Now they have given us the weight, not the moles. So we have to find the number of moles of aluminum. Number of moles of aluminum is weight of aluminum, that is 54, divided by the gram atomic mass of aluminum, that is 27, which is equal to 2. So here the number of moles of aluminum is equal to 2. Got that? Now number of moles of oxygen is equal to, mass is given as 320 and it is divided by 32, that will be equal to 10. So we got it as 10. Now just find out the N by SC value. N by SC, here it is 2 by 4, that means 0.5. Here it is 10 by 3, that means 3.33. So what is LR? LR is, aluminum is our LR, right? Yes, aluminum is our LR. Now we have to find out the mass of Al2O3. So in order to find out the mass of Al2O3, what we have to find first? We have to find out the number of moles of Al2O3. So we can apply the mole analysis here. While applying the mole analysis, only consider the aluminum. So number of moles of aluminum by stoichiometry is 4. Number of moles of Al2O3 by stoichiometry is 2. So number of moles of aluminum is 0.5. 0.5 into 2 divided by 4 equal to number of moles of Al2O3. Right? So here we got the value of Al2O3 as 0.5 into 2, that is 1 by 4. So I'll do in the next page. No, I'll do it here. The number of moles of Al2O3 is equal to 1 by 4. Now what is the weight of Al2O3? We know that weight of Al2O3 by molar mass of Al2O3. What is the molar mass of Al2O3? 27 into 2, 54, and 16 into 3, that is 48. 54 plus 48, that is 12, and 102. 102 is equal to 1 by 4. So weight equal to 102 by 4, that will be equal to, I'll do it here. Weight equal to 102 by 4, that will be equal to, you can cancel with 2. If you cancel with 2, we will be getting 51. So 51 divided by 2, 51 divided by 2 is equal to 25.5 gram. 5.5 gram. That will be the final answer for this question. I hope so. Is there any doubt, students? So we have 4 aluminum and number of moles of aluminum is 2, right? So yes. .5. Yeah. Hope this is clear for you. So we got the value as 25.5. Okay, students. Hope everything is clear for you. If not, you can just ask me any doubt now so that I can give you the reply for that. So let's check it once again. So here we know that the stoichiometry is 4, here it is 3, and number of moles of aluminum, here it is 2, because weight by molar mass, weight is 54 and molar mass of or gram atomic mass of aluminum is 27, so we got it as 2. Here it is 3 by 10, so 2 by 4, number of moles equal to 2 by 4 n by Sc, that we got it as 0.5. So now we will be applying the mole analysis with respect to the number of moles of aluminum, that is 0.5. Here we have 2. So 0.5 into 2 is 1. 1 by 4, that is 0.25, or 1 by 4 is the number of moles of aluminum oxide. And now you can find out the weight by using the formula number of moles is equal to weight by molar mass equal to 102, and number of moles is equal to 1 by 4. So weight equal to 102 divided by 4, that is equal to 25.5. It is clear? So hope this is clear, students. We will be meeting in the next session with a new chapter, that is atomic structure, another interesting chapter from physical chemistry, and I hope this is clear for you. This is a very important concept. You have to do more and more practice questions so that you will be it will be easy for you. Okay, students, thank you. We will meet in the next class. Until then, bye bye and take care.